Hello and welcome to another insightful chemistry tutorial video. Today for chapter 8, I will be going over how to determine the lattice energy of an ionic compound. If you're ready, I'm ready. Let's begin. What is lattice energy, you ask? Well, by definition, the lattice energy is the energy required to completely separate a mole of a solid ionic compound into its gaseous ions. So before I get into actually solving the problem, I must first give you some important information, and that is that we can quantify the energy involved with the electrostatic interaction using Coulomb's law. And the second thing is that lattice energy increases with the charge of an ion and increases with the decreasing size of atoms. When finding the lattice energy, there are actually two ways we can go about finding it. The first one is through a mathematical approach, and that is by using the formula E is equal to K times Q sub 1 times Q sub 2 over D. Now, for the Q's, I have the numbers next to it because when I was doing the equation, I was not able to do subscripts, but just know that it's Q sub 1 and Q sub 2. And in this instance, K is a constant, which is 8.99 times 10 to the 9th joules per mole per coulomb squared. Q sub 1 is charge of the first ion, Q sub 2 is the charge of the second ion, and D is simply the distance between the ion. The second way to find lattice energy is by simply quantifying them and listing them from highest or the lowest amount of lattice energy. And in my opinion, it is the easiest way, and you will still get the same answer as if you were to do it mathematically. But shh, don't tell anyone I told you. So here's an example of how to find the lattice energy. So the question reads, which compound, ammonium chloride or chloroform, has the highest lattice energy? Now, when you solve this, you can either do the first way, which is the mathematical approach, or the second way, which is the easier approach, and just simply listing them from the highest lattice energy or the lowest. But either way, you'll still find which one has the highest when you do it either way. And I will show you how to do it coming up. So I have gone with the easier of the two and decided just to list them from the highest to the lowest, or the lowest to the highest, whichever one you feel necessary. And in order to do this, we have to follow two different steps. And the first step is to indicate the charges for each molecule, and step 2 is to compare each molecule by either size or charge. So because I have chosen the second way, I will show you why it is actually easier, and either way you will still get the same answer whether you decide to do it the second way, in which I'm doing, or you proceed and do it with the mathematical way. Anyway, so step 1 is to indicate the charges for each compound. I'm sorry, it should say compound, but I have molecule, but you know it's compound. But anyway, so for the first compound, aluminum chloride, aluminum has a positive 3 charge, which is indicated by the +3. The chloride has a +1 charge. And then so for the second compound, it was chloroform, which is CHCl3. Carbon has a positive charge, hydrogen has a +1 charge, and chloride again has a +1 charge. For step 2 is to compare the sizes or the charge. And if you want to compare the sizes, all you would have to do is look at the periodic table and just compare the distances between the two. But since none of the molecules that we have are on the same row of the periodic table, we would just go ahead and compare the charges. So just by looking at it, we can see that aluminum chloride has the biggest charge out of both of them. So like it says here under step 2, aluminum has 3 times the charge that carbon does. So essentially your answer is that aluminum chloride has the highest amount of lattice energy. I hope that you learned a lot from this video, and please continue to do practice problems in your book or whatever your professor has provided you. And if you need more clarification on this video, do not hesitate to put it in the comment section below or message me, and I will be glad to help you out. So until next time, see you. So